So let's discuss a problem from GATE 2021 physics, which is from classical mechanics. So it is related to uh, a new Lagrangian and finding the new Hamiltonian momentum, etc. like that. So the problem is the time derivative of a differentiable function is added to the Lagrangian such that, so this is Lagrangian as we know, it is a function of generalized coordinates q and qi's and generalized velocities qi dot and time t. So the time derivative of the, so this function's time derivative has been added to this Lagrangian. So here you can see the new Lagrangian is this, which is the addition of this this old Lagrangian and time derivative of this function. So where qi dot and t are the generalized coordinates, generalized velocities and time, so as we all know, and pi is the generalized momentum and h. So pi is nothing but generalized momentum and h the Hamiltonian associated with L of qi dot t. That means this is the Hamiltonian for this whole Lagrangian. So this is the Hamiltonian for this Lagrangian, but not for L dash. For L dash we need to find out. So here they have mentioned if pi dash and h dash are those associated with L dash, they have given in the question. So this, so here L and H are old Lagrangian and Hamiltonian, and the L dash and H dash pi dash are new ones, or those associated with L dash. The correct option is R. So now we need to see which options are correct among the following. So that is the question. So first of all, so in the question they have given about this new Lagrangian. So the same we have to take. So new Lagrangian is this. Now we need to simplify this new Lagrangian. So L is as usual like that, and d by dt of g. So here if we see g is a function of q and t, then that is generalized coordinates and time. So first of all we need to differentiate g with respect to generalized coordinate, as it is a function of qi. So if suppose f is a function of x comma y, so in the process of differentiation or partial differentiation, what we used to do is differentiate this function, partially differentiate it with respect to x as well as with respect to y. So in this here also we need to partial differentiate it with respect to this q as well as time. So here you can see this term. So this term is partially differentiating g with respect to q. So this is the thing. And again, as this is a time derivative, finally we end up with this dou qi by dou t. That means actually generally it is dg by dt. So if we just neglect these two terms, what we would get is again g by t form. So dimensional, according to the dimensional analysis. And next is finally and partially differentiating this g with respect to time. So this is normal derivation, this is partial differentiation, partial derivative. So this is the expansion of this term. And now another thing is L is as usual, it is written like that. So here next is this dou g by dou qi is written as usual, and this dqi by dt is nothing but qi dot, and this dou g by dou t is same as usual. So this is the expansion of this Lagrangian. So now pi dash is the new momentum, so that could be obtained from the new Lagrangian by differentiating new Lagrangian with respect to this generalized velocity, that is dou L dash by dou qi dot. That is pi, if we see pi is nothing but, So pi is could be written as pi is equals to dou L by dou Qi dot. In the similar manner, this pi dash could be written as dou L dash by dou Qi dot. Here Q is not changing. So next, so if we do so, what would happen is dou L by dou Qi dot based on this expansion. So dou L dash, this is L dash, this is nothing but L dash, L plus dg by dt. In simple, L dash is nothing but L plus dg by dt. So based on this, if we differentiate L dash, so dou L by dou Qi dot, and similarly dou g by dou t, we have found expansion of dou g by dou t. So this is the expansion of dou g by dou t. So if we differentiate this one with respect to dou Qi dot, so this term, so in this term, this is kept aside, and differentiating with this one with respect Qi dot would be 1. That is dx by dx is nothing but 1. Differentiation of x with respect to x is nothing but 1. So like that, here also differentiation of Qi dot with respect to Qi dot is 1. So only this term would remain. So that is the term here, dou g by dou Qi. And as this is time derivative, so there is no Qi dot term, so this partial differentiation would become 0. Next, so finally we would end up with these two terms, and here this is nothing but pi, dou L by dou Qi dot, as we have discussed. So this is pi, and dou g by dou Qi, so this is nothing but pi dash. And now another thing is, finally we have got pi dash in terms of pi and dou g by dou Qi. Now again what we need to do is differentiating on both sides. So in order to find whether pi dash is conserved or not, we need to take this step. So if you are differentiating with respect to time, so on the left hand side dou pi dash by dou t, on the right hand side dou pi by dou t, and this differentiating with this with respect to time is this. So here from this you can see, if dpi by dt is 0, that means if pi is conserved when the time derivative of pi is 0. So this is nothing but pi is conserved. The meaning of this is pi is conserved. Then we see that pi dash is this. Even if this term becomes 0, but this term, we can't say whether this term becomes 0. We can't say that dou g by dou Qi is constant of time. We cannot say from the given function, because g is a function of both Qi and t. So we cannot say. So g could be like this, q t square qt, like that. It also could be like this function. So if we differentiate this with respect to q, what we would remain is t square plus t. So if we differentiate this with respect to time, it is not a constant of time, where this is not be equal to 0 if we differentiate this term. So that is the meaning of this. We don't have any information regarding the form of function of which g takes. So finally, as we are having dou pi dash by dou t is equals to this term, so we cannot say that pi dash is conserved. If pi is conserved, it is not necessary that pi dash is also conserved. That is, its derivative with respect to time is 0. So we cannot say. So that is the thing. And next is, now we need to find the new Hamiltonian. So formula for Hamiltonian, that is relationship between Hamiltonian and Lagrangian, is this: H is also summation pi Qi dot minus L. So here also same summation in the place of pi dash, in the place of L dash. So in the place of pi dash we have found normally, this is nothing but pi dash. So that one we need to substitute here into Qi dot minus L dash. L dash also which is given in the question, L plus d by dt of uh, g qi comma t. So that is was given in the question, L dash L plus dg by dt, and this is for this is as usual Lagrangian, and this is for the ith coordinate. In the similar function we might be having some n coordinates like that, n coordinates, not this is just for ith coordinate. The coordinate may be first, second, third, fourth coordinates and so on. So hence we have to use summation here. So finally this is nothing but L dash L plus summation I d by dt of g of qi comma t. So next is, and summation, now we need to multiply here. So summation pi qi dot summation after taking summation inside, and we would have this, and here this L we are just keeping this aside because this is nothing but old Hamiltonian, summation pi qi dot minus L. So we are just gathering them, and next from this we are having this term summation I dou g by dou qi dot, and from here minus into plus minus dou by dou t, and this summation could be taken out. So here y means we are having summation here, and here also we are having summation, so it has been taken out as common. So next here dou by dou t, sorry, d by dt of g of qi comma t, and next we are just expanding this. So this is nothing but this term. So this term has been written here. So dou g by dou qi dot summation along with summation, and this term we have already expanded. So differentiating g with respect to qi and then with respect to t. So we have seen this at the start. So dou g by dou qi into qi dot minus dou g by dou t. So finally what is happening here is, so this is plus and this is minus, both of them are same but opposite signs, so they would get cancelled, and finally what would remain is h dash is equals to h minus dou g by dou t. So this is the final thing that would remain. So we have found out the new Hamiltonian. So now we need to check for the correct options. So actually h dash we have got h minus here. So here you can see it is h minus, not h plus. And next is pi dash is pi plus dou g by dou qi. So pi dash is pi plus dou g by dou qi. So this option is correct, and if pi is conserved, then pi is necessarily conserved again, but we have found that it cannot be conserved. If pi is conserved, then pi cannot be conserved from this derivation, because it is this here this dou g by dou qi may be a constant of time or may not be a constant of time. So hence this is not the correct option. And this one, both L and L dash satisfy Euler Lagrange's equations of motion. So we know that Lagrangian equation of motion is nothing but d by dt of dou L by dou qi dot minus dou L by dou qi is equal to 0. So as here we see, in general Lagrangian should be a function of generalized coordinate, generalized velocity and time. Here also if we see, we are getting generalized velocity here, and here some just a time derivative. So both of them are belonging to the same system, and both of them are just functions of this generalized coordinate, velocities and time. So they both of them would surely definitely follow this Euler Lagrangian equation of motion. So for this, A and B are the correct options. So thank you.